what is a linked list? Linked list is a linear data structure. If we try to delete a node from the linked list which is empty, the condition is called as underflow. Each node in a tree has 0 or more child nodes which are below it in the tree. Linked list is a collection of nodes and each node consists of, there are two parts, one is a data field and one for reference to the next node. Dear students, welcome to CS revision classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us continue our discussion with the chapter data structure, chapter number 4. So, in this session, we are going to talk about a non-linear data structure. They are linked list and trees. And here, linked list is a linear data structure. Now, let us see what is a linked list. Linked list is a linear data structure of data elements called nodes, and the linear order is given by means of pointers. And here in the previous example, when we talk about stacks and queue, we use the word elements. So here, because we are implementing stack and queue through arrays, so we use the word array elements or data elements. But here, with respect to linked list, we use the word called nodes. So it is a collection of data elements or it is a collection of nodes. And each node contains, there are two parts. One is the data field, second one is the reference to the next node. So we'll understand in the next slide. So here each node, it is linked list is a collection of nodes and each node consists of, there are two parts. One is a data field and one for reference to the next node. Now the first part contains the information, that is the data, and the second part contains the address of the next node in the list. So this is also called as link field. So what is a linked list? Linked list is a linear data structure and it is a collection of nodes. Each node is divided into two parts. There are two fields. One is data field and second one is address field. So data field is nothing but the information part of it, and the address field, or it is also called as link field, it contains the address of the next element. So this is the definition of a linked list. In the next slide, we see this is how we represent a linked list. So what is a linked list? So it is a collection of nodes. This is one node. This is one node. As what you have seen, each node is divided into two parts. One is data field, second one is link field. So data field is the field where it contains information or the data, and the second part or the second field is called link. It contains the address of the second element or the next element. Now this is how we represent this linked list. So suppose this is the node. So this is the first node. The first node here, this is a start point. So this pointer, start pointer, it contains the address of the first node. And in the node, this is the information data field and this is the link field. So it contains the address of the second node. So this is how the linear data structure linked list is representing in computer memory. So this is a node. It is a collection of nodes. And this arrow mark indicates, so this node contains the address of this node and so on. So this is a linked list. Now in the above picture, link with the four different nodes, each node contains two parts, and the left part is called represents the information and the second part contains the pointer to the next field. So this is what we have seen in the previous slide. So this, suppose this is a one node, this is the information node and this is the address of the next node. The pointer start gives the location of the first node. So here this pointer also represents as a head point, or it is a head pointer, or it is a start pointer. So here this is the one, this pointer contains the address of the first node of a linked list. Note the link field of the last node contains the null. So In the previous example, if you look at this, the last node contains the null. So this indicates null. Here X, it represents null, means it indicates that is the end of the linked list, or this is the last node of a linked list. In this example, there are 4 nodes, and the start pointer contains the address of the first node, and the last pointer in this example, it contains, and in the address field it has X, it stands for null, means this is the last node of a linked list. So this is a linked list. Now in the next slide, let us see what are all different types of linked list. Here we have 3 types. So one is singly linked list, doubly linked list, and circular linked list. Now let us see the definition of single linked list. The singly linked list contains the 2 fields, the data field and the link field. So this is the node, and the data field contains the data of that node, while the link field contains the address of the next node. And since there is only one link field in each node, the linked list is called singly linked list. So what is the definition of singly linked list? So this each node, or in a singly linked list, there is only one node, so one link to the next node. That is the reason it is called as singly linked list. Next one is circular linked list. So here, if the link field of the last node contains the address of the first node, so such a linked list is called as circular linked list. So look at this example here. So this is a node and this is a linked list, and these are different nodes, and start is the pointer. It contains the address of the first node, and or another name is header pointer or header node. And here if you observe this, the last pointer, the linked list or the link field of a last node of a linked list contains the address of the first node. So it means that, so this is the definition of a circular linked list. In the next slide, doubly linked list. So what is a doubly linked list? Here it is a linked list in which each node points to both to the next node as well as to the previous node. So look at the example here. So this is the node. So in this example, there are 3 parts. So in this type of doubly linked list, each node will be having 3 fields or 3 parts. One is the information of the data, and here the first one is it contains the address of the next node, and this contains the address of the previous node. So in doubly linked list, each node contains 3 parts. One is forward, back, and information. So here this back pointer, see this is the back pointer, it contains the address of the previous node, and this forward pointer, it contains the address of the next node. And INF, info stands for it contains the actual data. So this is a doubly linked list. In the next slide, we will see the definition of what is a garbage collection. If a node is deleted from the linked list, or if a linked list is deleted, we require the space to be available for future use. So here, if any linked list or any node in the linked list is deleted, those nodes are stored in a separate linked list that is called as garbage collection. The memory space of the deleted node is immediately reinserted into the free storage list. So here we have a separate list, a separate linked list, which all these free separate linked list, it contains all the deleted nodes from different linked lists. So here the operating system of the computer periodically collects all the deleted space into the free storage list. This technique of collecting deleted space into the free storage list is called as garbage collection. So what is a garbage collection? It is nothing but a linked list, or it is a process where all the deleted nodes or deleted space from different linked lists are stored in a separate linked list or a free storage list. The process is called as a garbage collection. And next definition is called what is underflow. Here, if we try to delete a node from the linked list which is empty, the condition is called as underflow. So what is underflow? This is a condition where we are going to or we are trying to delete the nodes from an empty linked list. The condition is called as underflow. In the next slide, we will see what are non-linear data structure. As we have seen in the beginning of the chapter, there are two types of data structures, and here linear data structure and non-linear data structure. Now, in non-linear data structure, so non-linear data structure is a data structure in which data item is connected to several other data items so that a given data item has possibility to reach one or more data items. So, if you look at the example of stack, queue and linked list, here the one item is followed by another item. So here in a linked list, the link field, it contains the address of the next node. And even with respect to stack and queue, as we are implementing through arrays, the index of array start with 0, then 1, 2, 3, 4 and so on. So in all the elements are stored in a sequential order. But if you look at the non-linear data structure, here the one data structure in which the data item is connected to several other data items. That's the definition of non-linear data structure. And the data item in non-linear data structure represent hierarchical relation. Each data item is called a node. And here each data item is called a node. And example of non-linear data structure are graphs and trees. Graphs and trees are example for non-linear data structure. Now let us see what are trees. A tree is a data structure consisting of nodes organized as hierarchy. So look at the example here. So this is an example of a tree data structure. And here these are all called nodes. Here this is 1, 2, 3, 4, 5, 6, so on. All these are nodes in a tree. So tree it consisting of nodes. It is organized in a hierarchy. See what do you mean of hierarchy? So this is the first node and these two are the two nodes from this node, and this is again the three nodes for this, and again there are two nodes for this node. And see, this is the meaning of hierarchy, and here these are called nodes. And if you look at the diagram here, we can make out, see the first node of a tree is called a root node. So here we can learn the few definitions with respect to tree. The first node of a data structure tree is called a root node, and this is ends for this. This is an ancestor node, and this is the descendant node of the node. For example, node 3 here, and the last node of a tree is called leaf node. It is a terminal node or it is a leaf node. And if you observe this here, see this is 1, this is level 1, and this is order 2, and this is order 3. So this is called the order of the tree. Here order of order 3 here, because this is a root node. From here we have one level or first level. So this is second level and this is level 3. So this is level 3. That is the meaning of it is an order of 3. This is a data structure of the order 3. This is an example for tree data structure. Now in the next slide we will see some of the definition or terminologies. So one is a now node. What is a node? The data structure in which it may contains a value. The node is a place where it contains a value or data items. So or it can be a condition or it represent a separate data structure. So that is the content of each node in a tree. And each node in a tree has 0 or more child nodes which are below it in the tree. So here, what is the child node? See, suppose if you look at this example, if you look at this example, this is a root node, and this node there are two another sub nodes, or it is called a subtree, and these two are called child nodes. And if you look at this example here, for this particular node, there are two nodes here. These two are called as child nodes. That is one more definition with respect to tree. A node that has a child is called as the parent node, or ancestor node, or superior node. So here, each node that has a child node. In this example, if you consider this is a child and this is another child of this node. So these are the two child nodes, and this is called as a parent node. That is the definition of a parent node. In the next slide, the height of a node. Next definition is, the height of a node is the length of the longest downward path to a leaf from the node. So this is, I repeat, length of the longest downward path to a leaf from that node. The height of the root is the height of the tree. Now if you look into that, here you can make see here, this is the starting point, and here is the level 2, and this is level 3, and it goes on like this. So this is, as we have seen, it is the node of the order 3. There are 3 different levels. This is nothing but hierarchical order. So here the height stands for from the leaf node to the root node, the distance or number of nodes. It indicates the height of the tree or height of the node. Next is the depth. The depth of the node is the length of the path to its root. So that is to its root path. So for example, for this root, if you talk about this, so for this root is this, and for this root is this. So for this is the depth of a node. Next one is the topmost node in a tree is called the root node. So what is a root node? The topmost node in a tree is called a root node. See, these are all different terminologies with respect to tree data structure. In the next slide, an internal node or inner node is any node of a tree that has a child node, and this it is not a leaf node. So what is internal node? If you look at this example here, see, this is the leaf node, there is a last node. So what is, any node, internal node that has child node. In this example, if you consider this node, it has a child node here. So this is known as internal node, and leaf node is the last node of a tree. A subtree, next definition is subtree. What is a subtree? Subtree of a tree is tree consisting of a node and all of its descendants in T. So the meaning here is, see, this is called a subtree. So this is the tree, this is a node, it has 3 subnodes. These are the 3 different nodes. So this forms a separate tree. It has ancestors as far as descendants. So this is an example for subtree. Now let us see, next definition is a binary tree. So tree is a nonlinear data structure. Under that we have a binary tree. See, what is a binary tree? The simplest form of tree is a binary tree. A binary tree is a tree in which each node has at most 2 descendants, and a node that can have just 1, but it cannot have more than 2. So what is the meaning of, or the definition of binary tree? A binary tree, it is a tree, a simple form of tree's data structure. It consists of only there are 2 nodes or 2 child nodes. Look at this example. If you look at this example, see, suppose this is the root node, the topmost node of a tree, and it has only 2 nodes. So, and again, if you consider this example here, in this it has only 2 nodes. So this is called as a binary tree, and either it can have 1 or 2, maximum is 2 nodes. So this is the definition of binary tree. So this binary tree consists of a node. It is called a root node, left and right subtrees. So in this example, this is a root node and it has left and right subtrees. Both subtrees are themselves binary tree because
if you look at this example, this is a node and it has only two nodes. Itself is a subtree of a binary tree. The importance of binary tree is that you can create a data structure that mimics yes or no decision making process. So this is one of the application of a binary tree. In the next slide, we will see the definition of few terms. Here, root node. In binary tree, root node is the top of the tree, and the leaf node, the node at the bottom of the tree, is called the leaf node. And what is a complete tree? So here, a tree in which each leaf is at the same distance from the root. I mean, all the nodes have maximum number of 2 subtrees. So this is a definition of a complete tree. Next one is height. What is height of a binary tree? The number of nodes which must be traversed from the root to reach the leaf node of a tree. So that is the height of the tree. So what is the height of the tree? Suppose if I want to say what is the height of this node here. See, if you want to reach this from the root, it has to pass through from here to this and this to, and here to this node. So this is height of this node is 2. So this is the definition of height of binary tree. In the next slide, we will see what are graphs. So graph is another type of a tree data structure. So here graph is a set of vertices and edges which connect them. So a graph is a collection of nodes again. So it's a collection of nodes called vertices, and the connections between them is called edges. So if you observe this, again graph is a collection of nodes. See, these are all different nodes here. In this example, there are 5 nodes. And here, the collection of nodes called vertices. So these are all called vertices, and the connection between them is called edges here. So here, from A, B, C, D, E are called the vertices, and the connection between from A to B, for example, and B to C, C to D, and D to E are called edges. So this is an example for non-linear data structure. Students, so far we have discussed about a linked list and a non-linear data structure. Under that, we have learned few definitions of what are trees and graphs. Now let us continue our discussion in my next class. Thank you very much.